Alright, in this video we're going to be looking at some more things that deal with a multiplication rule. In this case, it's going to be complements and conditional probabilities. So what we'll look at is the probability of at least one and the conditional probability. Okay, so let's talk about the probability of at least one. Now, the probability of at least one is in relationship to the complements. Okay, so the phrase at least one has the same meaning as this: one or more. Okay, and if you were to write that as an inequality, at least one would be something like this. Let's say x is greater than or equal to 1. That's basically what that means. If you were to write that in symbolic notation, at least one means one or more, or I can say x is greater than or equal to 1. Okay? Now, for the complement of at least one, what that means is this. It means that you get no occurrence of that event. Okay? So the complement of at least one means that you get no occurrence of that event. Okay, so let's say you have the probability of getting at least one boy. Now, if we want the complement of that, it would be this: the probability of getting no boys. So the probability of getting no boys will be the complement of getting the probability of at least one boy. Okay? So here's the procedure for finding the probability of at least one of some event. Okay, this is what you need to do here. You have to let A represent getting at least one. And then second, a complement will mean getting none of the event. Then step number 3, you'll find the probability of a complement. And of course, if you recall, what the complement of A, the probability of a complement means the probability that event A does not occur. And then step number 4, subtract the probability of a complement from 1. So in other words, it's going to be this particular situation. The probability of, let's say, at least one of the occurrence of A is going to be equal to 1 minus the probability of no occurrence of A. Alright, that's basically what that means. Alright, now let's look at one example that deals with the probability of at least one. Okay. And it says here, if a couple plans to have 7 children, what is the probability that there will be at least one boy? Assume boys and girls are equally likely. If that probability is that probability high enough for the couple to be very confident that they will get at least one boy in 7 children? Okay? Now, to find the probability of at least one boy, let's find first the probability of getting no boys. Okay? The probability of getting no boys is the same as saying the probability of getting all girls with 7 children. Okay? Now the probability of getting one girl will be 1/2. So for all 7 children being girls, we're going to multiply by 1/2. So 1/2 will be used as a factor 7 times. As we're dealing with 7 children. And if I multiply numerator times numerator and denominator times denominator, I'm going to get 1 over 128. So the probability of getting no boys, or the probability of getting all girls, will be 128. Okay, now I'm going to use the complement to get the probability of at least one boy, which will be 1 minus the probability of getting no boys. Now the probability of getting no boys was 1 out of 128. So this will be 1 minus 1 over 128. Okay? Now I need to change that 1 with the common factor of 128. 1 whole with the common factor of 128 would be 128 over 128. Minus 1 over 128, which will be 127 over 128. So the probability of getting at least one boy will be 127 over 128. Okay, now, to do that 1 minus 127 over 128, 1 minus 1 over 128 on your calculator, you'll do 1 minus, and then left parentheses, 1 divided by 128, close parentheses. Then hit the math key, then select number 1 for fraction, and then hit enter. You'll see that it will be 127 over 128. Okay? So that's how we apply the probability of at least 1 to this particular problem. Okay, the next thing I want to talk about is the conditional probability and how to find probabilities using the conditional probability rule. Alright, conditional probability is the next thing we'll talk about. And by definition, the conditional probability of an event is this. It is the probability obtained with additional information that some other event has already occurred. It's a probability obtained with additional information that some other event has already occurred. Okay? And we use this notation that the probability B slash with the vertical bar and then A. That means that the probability of event B, given that event A has already occurred, or you can say the probability of event B given A. Okay. Now they do give you this formula to use. The probability of A and B divided by the probability of event A. Okay. But in reality, we don't have to use this particular formula, because you have to think of what's the probability of A and B happening, and then get the probability of event A happening, and divide that. However, there is an easier way to find conditional probability, and that's using the intuitive approach. So I'll go ahead and give you the intuitive approach. Okay. What this means is this. The conditional probability of B occurring given A has already happened what's going to happen is it's going to reduces the sample size. And that's very important. Okay? When you take the conditional probability of B occurring given A has already happened, you're going to end up reducing your sample size. Okay? And the reason for that is this. In this case, we will only focus on the total number pertaining to event A. Okay, that's very important. So here, when you're dealing with a conditional probability, you're going to be reducing your sample size because you're only going to be focusing on event A and just that total number. So in this case, let's look at this example. Here the data represents the number. The data represents the results for a test for a certain disease. Assume one individual from the group is randomly selected. Find the probability of getting someone who tests negative, given that he or she had the disease. Okay, so now what we're trying to find is this. The probability that this person tested negative and is given that the person has the disease. Okay? Now, here's where we use that intuitive approach. What I'm going to box in is the fact that this person has the disease. So here the individual has the disease, which is your yes column. So I'm only including this. And I'm only going to focus on the total number of items that are in the yes column. So 128 and 31 would give me 159. Okay? So 159 individuals have the disease. So in this case, my denominator is just 159. And out of the 159, how many tested negative? In this case, that's 31. So there's your numerator right there. And that's pretty much what your answer is going to be. The probability that a person of randomly selecting someone who tests negative given that he or she has the disease will be 31 over 159. And as a decimal, it will be to 3 decimal places 0.195. Okay? So that's how we use this intuitive approach for conditional probabilities. Okay? All right, another example of that would be this. Here the table below shows the results from experiments with polygraph instruments. Find the positive predictive value for the test. The positive predicated value for the test. That is, find the probability that the subject lied given that the test yield a positive result. Okay, so in this case here, let me go and add up my rows and columns here before I do anything. This will be 51, 43 and 10 will be 53, 20 and 43 will be 63, and 31 and 10 will be 41. So this should end up being 104. Okay? Now, what I want is the probability that the subject lied given that the test revealed a positive result. Okay, so right now I'm going to be focusing on given that this person had a positive test result. So it's only this row that I'm going to be focusing on right here. Okay. Now, the number of positive test results, or the total number of positive test results was 63. So that 63 would be my denominator. And out of those 63, how many lied? How many subjects lied? In this case, it's 43. So the probability that of selecting an individual subject that lied, given that the test yielded a positive result, would be 43 over 63. And if you were to divide that as a decimal, it would be 0.683. Okay? So the probability that the subject lied, given that the test yielded a positive result, would be 0.683. Okay, there's one more thing that I need to look at before we finish with this video, and that is what they call confusion of the inverse. Confusion of the inverse. If you have the probability of event B given that A has already happened, that's not the same as saying the probability of event A given that B has already happened. Okay? So to incorrectly think that these two are equal, that would be incorrect. We call that confusion of the inverse. Okay? Because the probability of event B given that A has already happened is not the same as the probability of event A given that B has already happened. And one example of that would be this. The table below displays results from experiments with polygraph instruments. Find the probability that the subject lied given that the test result was negative. Compare this result with the probability of selecting a subject with a negative test result, given that the subject lied. Or the probability that the subject lied, given a negative test result, and the probability of a negative test result, given that the subject lied, equal. Okay, so let's start with this. Okay, let me add the columns up and rows up. 46, 56, 59, 43, and the grand total is 102. Now here I want the probability that the subject lied given that the test result was negative. So I'll just say negative test. Alright, now we're given that the person had a negative test result, which is going to be this row here that I'm boxing in green. Okay, the total number of negative test results was 43, so that's going to be my denominator, and not the 102. Now, out of those 43 negative test results, how many subjects lied? In this case, that's 12. So it'll be 12 over 43, and if we convert that to a decimal, to 3 decimal places, that'll be 0.279. Now we want the probability that we get a negative test result, or I'll just say negative test, given the fact that the subject lied. Okay, now in this case, it's going to be this column in red where the subject lied. The total number of subjects that lied was 56. So here the 56 will be in the denominator. And out of the 56, how many negative test results were there? There were 12. So it'll be 12 over 56. And if you convert that to a decimal, that'll be 0.214. And as you can see here, that these probabilities are not equal. Okay? So this is an example of the confusion of the inverse. So here we can say that both probabilities are not equal. Okay? So that concludes here that the probability that event B, given that A has already happened, is not the same as the probability of event A, given that B has already happened. Okay? So that's what we call confusion of the inverse. Alright, so that's going to conclude this particular video on the concept of the multiplication rules when we're dealing with conditional probability and complements, especially with the probability of at least 1.